Hello, this is Mr. Jarrett, and in this video I am going to be taking you through the design process presentation. So first off, I posed these three questions. What is a design process? Why do we use it? And are there multiple types? So I would like you to kind of pause the video and ask yourself those three. Now, the steps of the design process that we are going to use for class are as followed. So step one is define the problem. Step two is generating concepts or ideas. Developing a solution is step three. Step four would be constructing and testing a prototype. Step five would be evaluating your solution. And step six is presenting it. Now you see this little chart that I put over here. You can kind of see there's a whole bunch of little in-between questions and arrows. It looks very confusing at first, but if you look closer, it kind of makes sense. So define the problem. Then you have to ask yourself, is that problem valid or justifiable? Meaning, is it even worth solving? If the answer is yes, then you move on. If the answer is no, well, then you just identified a new problem. Your new problem is, why isn't it justifiable? Okay, so it just kind of circles back. So if it was yes, you continue down generating concepts, making a whole bunch of different ideas. Okay, and the question you'll have to ask yourself from there is, after you have your ideas, is there technology exist? So does the technology exist? If it's yes, continue. Okay. If it's no, then you circle back through and notice you skip step one and you're actually back into step two. And the reason is because you've already identified that new problem. Okay, the new problem is the technology doesn't exist. So what do you need to do to solve that? Okay, continuing on, if it does exist, you develop that solution. Is the solution valid, meaning is it going to work? If so, you construct and test the prototype, and if not, you move back up, obviously, and you continue back down through. Once you construct and test it, is the prototype valid? So does it actually do what it's supposed to do? And that's from your testing results, you'll figure that out. If so, you evaluate that thing and you kind of see where you can improve. If not, then it goes back up to the design process. Okay, and then step six, you're going to present your entire solution. So that is presenting everything, what you found, your test results, new problems, old problems, how you're going to improve it in the future. Okay, so to break this down a little bit further, I'm not going to read all this stuff to you, but defining a problem. All right, so the example video that I showed you before this was called the Deep Dive documentary, where in this picture you can kind of see they tried to improve a shopping cart. Okay, so they gave them different problems of what they need to improve on it. And that was the identifying part or defining that. Okay, and you may have to ask yourself a whole bunch of different questions. So in this same stage, there's several little things that you do. One of them is creating what's called a design brief. So this is a written plan that identifies a problem to be solved, its criteria, and its constraints. So it's used to encourage thinkers of all aspects to think of all aspects of the problem before attempting a solution. Okay, so a problem statement defines the problem or task at hand in a brief sentence. Sometimes maybe this is a small paragraph. So it's really not a statement, but they just kind of say that. Criteria. So this is kind of two things. This specifies the materials that you're given to complete the task at hand. So sometimes maybe you're limited, okay, and money could be a part of that as well. And it also says it provides a way of evaluating or testing a possible solution. So this is another like way of posing questions to ask yourself about your solution. Okay, and the final thing is your constraints. So they are limitations or restrictions. Basically, it's things you can or cannot. Okay, stage two. So this is where you're going to generate concepts. Normally, here's where you're doing a lot of research, you're brainstorming ideas. Maybe you're making little mock-ups. So a mock-up, won't function, but it gets your idea down on paper. Maybe you're even making some concept sketches. Okay, like you can kind of see here that it's all labeled out. So in the video we watched, you saw they actually went and did some hands-on research. They went to a local grocery store. They saw how they functioned. So they stepped on them to see some safety. They saw how they bayed, or actually like went into one another for storage. And they talked to one of the store clerks there, who told them some insightful information about how they function, safety, and other information that they may need. They came back and they did some concept sketches. Some were super detailed, as you can kind of see. Some were not. Some people even made some mock-ups, maybe out of paper clips. And in this stage of brainstorming, really, this is a group technique for solving problems and generating ideas. Okay, it really stimulates creative thinking. So during the brainstorming process, the company that we saw had their own set of rules that was posted everywhere, and you can kind of break those rules down from 5 to 4. So the first one would be do not criticize ideas. So even though your classmates might have some ideas that you think are just hilarious or are never going to work, don't criticize them. Okay. And what you actually should do is you should work for quantity. Maybe come up with a whole bunch of ideas, and maybe their hilarious ideas might actually make you laugh and start making you think in a different way that might lead to a great idea. Okay. So working for quantity is also a huge problem that I've noticed a lot of students have. Right when I give them some type of challenge, they're all like, oh, I instantly know how I'm going to solve this. Well, that's fantastic, but what if it doesn't work? Yeah, what if it doesn't work? I would love for you as a student to show your maturity and say, hey, I'm going to think this way and I'm going to come up with an idea. And now I'm going to act like I never even thought of that. And I'm going to think of some other ideas. Because then what you might find is your ideas actually help one another and you can use a whole bunch of those ideas in combination. Okay. The next one would be welcome piling on. So this goes back to not criticizing. If a student in the class makes some type of idea or comment, don't criticize them, but instead pile on to that, maybe add on to it. Okay. Now, of course, there's a time and place and a mature aspect of this. Are you kind of tail spinning to the point where you're not even really on task anymore? Is it not worth what you're even saying because you're really not being serious? So piling on is supposed to uh, being an aspect of creating more or adding more to an already existing idea that came up from the group. And the last one is allow free for all. So meaning during brainstorming, it should be a fun atmosphere. This shouldn't be a quiet, very structured thing where no talking and come up with your own ideas. It should be free for all. It should have some fun with, of course, rules because we are in school, though. But once you have a whole bunch of ideas, you're going to use what's called a decision matrix. Okay, a matrix is like a chart. So a decision matrix is a tool or chart used to compare solutions. So you'll put all your different ideas in this, and you'll come up with some different criteria. So in this case, the whoever's chart this is, they have a cost, complexity, development time, and there's different judging methods. But normally down here, if you're judging it 1 out of 4, even if you have more than 4 ideas, you just judge it 1 out of 4, 4 being the best and 1 being the worst. You take yourself through this. So I'll give a couple examples. So for idea number 1, they put a 3. So is that a good cost, meaning it's cheap, or was it expensive? Most people would think, oh, well, 3, it was expensive. That's a bigger number than 1. Well, in this case, the higher the number, the better. So the higher the number, meaning the cheaper it is. So this was somewhat cheap. This one was very expensive. This one is extremely cheap. Okay, middle of the road, extremely cheap, and kind of cheap. Okay, so complexity, how hard is it to make it? And if you go down through middle of the road, it's really hard, middle of the road, it's kind of easy, it's really hard, it's very easy. Okay, development time, it's going to take way too long. It's going to take kind of average. It's going to be fast, somewhat fast, and very fast. And when you add up these high scores, you'll find out that maybe your original idea, the one that you initially said, oh, this is my best one, maybe it's not, if you actually break it down fairly. So in the video we watched, they used just a simple voting process because they had tons of different ideas. And their voting process was based on them just putting all of their ideas on the wall and using color-coded sticky notes. Like this one says bad idea. Okay. So they just use color-coded sticky notes. And sometimes they even piled on to those ideas with extra things. So number three, or stage three, this is developing a solution. So this is where you're going to do 3D modeling. So in the video, they didn't really do this too much. They didn't show them doing this. They said they really didn't have a lot of time to actually film all of that. But you can see this picture of this gentleman actually 3D modeling the seat of the shopping cart. Okay, stage four was constructing and testing. In the video, we did not see this at all as far as constructing. They said they did that overnight. So constructing, you're actually just making a testable prototype. Okay, a prototype. It's not a finished product, something that you can test out, and that would be a prototype. That is a functional, life-size, what you would call product, but in this case, prototype. Okay, so I put this picture down here because we all have cars that we've purchased or somebody purchased, and they are products. But before they ever get to market, they are built and crashed over and over and over and over. And yeah, it seems like a lot of wasted money, but they have to test out the safety, they have to test out the structure of this, the electronics. There's so many different things that they have to test out with this that they have to do this. They have to crush a whole bunch of cars so that they can make test reports, they can analyze that data, they can collect that data, and they can move ahead. So in the video, we didn't really see them fabricating too much. They just did real quick glimpses, as you can kind of see. But what they did do is they all made smaller prototypes, almost like the mock-up stage of a prototype, and before they made their final version of their prototype. So you can kind of see these are just some of the pictures. Number five would be evaluating that solution. So this is kind of doing an assessment. So the evaluation, accomplishing specific goals. Did you meet your criteria? Did you follow all your constraints? Okay, what's the trade-off between the benefits and risks, the pros and cons of your product or your prototype here? So you're going to evaluate its effectiveness, and you're probably going to reflect on this, okay? Maybe even recommend some improvements. And you're going to optimize or redesign the solution. So in school, we might not always have time to constantly go through the design process because it doesn't ever stop. You would redesign and redesign and redesign and redesign. Okay. And stage six, this is the presenting a solution. So really, this is the documentation stage, sorry, of your entire project. So maybe a project portfolio or a formal presentation. So what they did was they obviously had this video for us to watch. So that's their final presentation. But they also took this to the customers to and the store. So they had customers and they had store clerks actually give them some feedback. So they got real life feedback from people that used it. So I am not going to play this during this screencast, but I will say that this is a video that I found online that I kind of edited. I borrowed permanently, so thank you to this gentleman, whoever made this. And it will show you kind of the steps that we are going to be taking in our design process. So taking you all the way back to these first three questions that I posed for you. I asked you, what is a design process? Well, hopefully you figured that out by this presentation. And then I said, why do we use it? Well, obviously we use it to help ourselves improve something. So it takes you through an organized step-by-step process to design and improve some type of problem or task that we want to solve. Okay, and are there multiple different types? Of course there are. Look at what you do in science. Okay, your scientific notation follows something that's very similar to this. It just is, I believe it's 4 steps. It's just smaller than this and it's worded differently, but basically these are the overall steps that you're going to do in any type of process of design. So if I go all the way back to the end where I just was, the very end of this, after this video, I gave you kind of this little cartoon picture. So problem solving skills. If you sit here and you kind of pout about a problem and you get so overwhelmed about all the different things that go into your problem, it's going to be very difficult for you to make any decisions and go ahead. In this case, this person had a problem, they prepared, they assessed that problem, they solved the problem, they reviewed it. So what this is kind of showing in a comedy way is the design process helps us take all of these crazy thoughts and aspects of a problem into account, and we organize them so that we can solve those problems efficiently.